Hello guys, welcome to Machine Learning in Remote Sensing series. My name is Yuhan Zhou, and I'm going to talk about the introduction to selected open source remote sensing datasets. Nowadays, with the boom of deep learning, the datasets are becoming more and more important because deep learning is a kind of data-driven approach and relies on datasets for the end-to-end training. Although there are many famous datasets in the computer vision field, these datasets cannot be directly applied to the remote sensing field because of the huge domain gap between them. As a result, the remote sensing field needs its own dataset. Based on the research tasks of remote sensing, we can classify the remote sensing datasets into 4 categories, which are scene classification, object classification, semantic detection, and change detection. And now I'm going to introduce some selected datasets for each task. First, the scene classification task. Basically, the scene classification task takes an image patch as input and output the label of this patch. And AID is a benchmark dataset for this task. This dataset, AID, collects high-resolution images from Google Earth imagery, and it has a number of 10,000 images, which is made up of 30 aerial scene types. Besides, the images of these datasets are diverse because the sample images of these datasets are carefully chosen from different countries and regions around the world, and they are extracted at different times and seasons under different image conditions. And this increases the inter-class diversities of the data. The second kind of datasets I'm going to introduce is the object detection dataset. The object detection dataset also takes image patch as input, but its output is the bounding boxes of the objects of interest. And DOTA is a large-scale dataset for the object detection task. The images of these datasets are collected from different sensors and platforms, for example, Google Earth, Galvan 2 satellites, and aerial images. This dataset is developing and now reached its second version. In its second version, there are 18 common categories, nearly 11,000 images, and nearly 2 billion instances. And now I'm going to introduce datasets for the semantic detection task. Semantic detection task also takes an image patch as input, but its output is the corresponding semantic map of the image, with each pixel assigned to a category. GID 15 is a benchmark dataset for the land cover semantic detection. This dataset contains 150 pixel-level annotated Galvan 2 satellite images, which is labeled in 15 categories. And GF1 WHU is a cloud semantic detection dataset. It includes 108 level 2A Galvan 1 WFV images, and its spatial resolution is 16 meters. All the associated masks in this dataset label both cloud and cloud shadows. HRC WHU is another cloud semantic detection dataset. It comprises 150 high-resolution images whose spatial resolution ranging from 0.5 to 15 meters. Road flood is a benchmark dataset for the water semantic detection task. And this dataset contains 444 pairs of Sentinel-2 images and flood segmentation masks. The spatial resolution of this dataset is 10 meters. Finally, we arrive at the change detection dataset. Change detection, unlike the previous tasks, it takes bitemporal images as input. More specifically, it takes 2 image patches, one before change and one after change, and output a mask describing the changed areas. This dataset, LEVIR-CD, is consisted of 637 very high-resolution Google Earth image patch pairs. The images in this dataset come from 20 different regions that sit in several cities in Texas of the United States. It contains a total of around 31,000 individual change building instances. Now, in summary, remote sensing datasets are very important for both training and evaluation of deep learning models. And in order to make the trained models to have stronger generalization capabilities, the constructed datasets need to be both representative and diverse, including covering different time periods and covering different spatially heterogeneous regions. For now, for a particular remote sensing task, the image source is not that diverse. So the model trained in one dataset might not achieve the similar accuracy in another dataset with different image source, even though they might serve the same remote sensing task. And this motivates the need to construct datasets with multiple types of images for the same task. And finally, if you are interested in finding more remote sensing datasets, you could click the following links to find out the most suitable one for your own task. Thank you for your listening.